All right. So now what I'm going to do is I'm talking about chapter 3. I'm going to do what I did for chapter 2 where I just kind of bombard you with a bunch of stuff. Let me open up the lecture slides for chapter 3. All right, chapter 3. So I'll read the lecture slides next week, but here we're talking about creating objects. Okay, that's going to be something new, I guess. But we've already been creating objects. We created the scanner class. That's an object, right? Created a scanner object to read input from the user. We're going to talk about the string class, the random class, and the math class, the formatting outputs, and that's it. We'll talk about enumerated types and wrapper classes. Will we talk about wrapper classes? I talk about enumerated types and wrapper classes, but I'm not going to test you on them. It's one of those things where I'm going to introduce it to you so you know what it is, but I'm not really going to focus on testing you that on your midterm or on your final. Okay, that's something you're going to revisit in Java 2, but I'll kind of just go over it. It's just something that you should probably just go over so you know that exists. Okay, so really there's only 4 sections that we're going to focus on. Okay. Formatting output is really simple. I probably won't talk about it today because when I talk about it on the lecture, it's going to be really easy to understand and use. And I think only like a couple of problems from the book have you used the formatting classes, but I don't really test you on that on your midterm, except for knowing what package they live in. And I can't remember what other questions to ask. Anyways, I'll let you know when we get to that section what type of questions I'm going to ask you from formatting output. So really, these 2 that are highlighted are really what chapter 3 is about. String class, the random class, and the math class. I'm going to demonstrate those today, and that way I'll post the homework for chapter 3 up. If you want to get started in chapter 3 homework, you'll have everything you need to start on that homework. All right, so the first example is the string class. So I'm going to make a new file. I'm going to save this. I'm going to hop up one directory and make a new folder called chapter 3. I'll call this one string demo. And save it as Java file. All right, so public class. Oh dang, I copied the wrong thing. A public class string demo public static void main string array arguments, and then I'm going to show you a demo. But before I do that, I don't know if I've done this before. I'm getting this class and my Java 2 class mixed up. I don't think I've done this yet. So there is something called the Java API. You just Google it. And this is for 7. You could probably might want to look for 8, or 7 will work because a lot of things that we're covering in this class haven't really been updated. Okay. So from here, what we can do is we're going to have to know that the string class is part of the java.language package. Anything in the java.language package is automatically imported for you. That means you don't have to import like the way we did for the scanner class in order to use that class within a program. If I click up top, I clicked on java.language, and these are all the classes that are part of the java.language in this little frame here. The one that I'm looking for is the string. I'm going to click on that. And there is, if you can read all this, it's a lot of good information. The book actually tells you what it wants you to know, and I'm going to kind of go off what the book wants you to know. So there is a bunch of methods on the string class. Like all this right here, those are all methods from the string class. There's this table here, right? Oop, went too fast. Okay, like those are methods that you can invoke on a string object. Actually, the top part was constructors. Here, under method summary, there's only, I don't know, like, I can't remember, maybe like 10 methods that the book wants you to know. Okay, and I'm going to want you to know those as well. So I'm going to go over the 10, but there's actually plenty of methods that are available through the string class, and they're all listed right here. Okay, that you can This is the Java API. You can read about Java classes, particular Java classes you want to know more about in this API. All right, so I'm able to create a string, and I'll just say like name is equal to, I'll put my name. Actually, maybe I should do my first name and my last name. And then I'll just, I'll do this. Now it's going to call full name, and that's basically going to be my first name, and put the space, and then my last name. All right, so I could do something like this. All right, so I basically just made 3 strings, okay, and I put some data in them. First one, I just put my first name. The next one was my last name. I just put my last name, and the full name, I put my first name and my last name, but with a space in between them. All right, those are 3 different string objects that I created. So when I come over here, I have to go up to chapter 3. Dang it, chapter 3. All right, and then compile. Forgot what I named it, string demo. Okay, compile, and then run. All right, I'll just get that output. Pretty simple, okay, but because this data is actually what we call an object, right? In chapter 2, we learned about primitive data types. Primitive data types have a defined size in memory, and they only take up that memory size of location in memory, meaning they can't be anything else. There's no attributes or methods that you can invoke on them. They're just regular data. It's just regular data. So you hear the term primitive data, that just means they're not objects and you cannot invoke any types of methods on them. Okay. Now the string, as you saw when I showed you the Java API, has a bunch of methods that you can invoke on them. So for instance, there is several. Let me just print out. I'll say like full name in uppercase. Okay, and what I'm going to do is I'll just say full name, and there's a method called toUpperCase. Okay, and then I'll just do the same thing, but also lowercase. Right, that's a real simple one. Full name in lowercase. I misspelled uppercase. All right. And come over here to lowercase. Now this is a method, so you have to put parentheses at the end. I didn't do that for the toUpperCase. So I'm gonna hop over here, clear my screen, compile, run. Okay, and you can see that when I made it uppercase, it just made them all uppercase. When I made it lowercase, it made it all lowercase. Now it's important to remember that the string is actually returning a string. It's not actually modifying the object there. So if I were to reprint out my full name after I call toUpperCase, toLowercase, you'll see that the original string is intact. It did not actually change, right? So the M is capital, both M's are capital, right? Up here I made it all uppercase, and then here I made it all lowercase. But when I actually printed out the value of that string, the M and both the M's were capital, okay? So it just returned another string with it in uppercase or lowercase. It didn't actually modify the existing string. A string is what we call immutable, meaning it will not change. Once you declare that object, the object cannot be changed. The data inside the object cannot be changed. Okay, so if I wanted my full name to be in all caps, I would have to save that new string back into full name. Okay, so those are 2 methods there. You have the toUpperCase, toLowercase. Let's see, what else we got? Oh, you have replace, which is actually pretty interesting. So I'm going to say replace M with A. All right, so I'm going to take my full name. Actually, I should probably make this capital. Capital M, capital A. Now this method is called just replace. It takes in two chars, the char that you want to replace and the char that you want to replace it with. Now remember, char literals are one quote, so I want to look for capital M and I want to replace it with a capital A. So now when I come over here and compile and then run, you can see that I was able to replace the M with the capital A. Now once again, the actual value stored inside of the full name variable did not actually change. It just made a copy of that and printed it out to the screen. All right, so that is replace. Let's see, 2 uppercase, 2 lowercase. Replace. There's trim. So let's just say that I had like all this extra white space on my. Actually, let me put all. No wait. I'm gonna do. All right, hold on. Let me Control Z this real quick. Okay, let's just say on my last name I had like a bunch of space in the front and a bunch of space at the end. Okay. All right. So when I actually print that out now, you'll see that it sees all this extra space on my last name. There's my full name, right? There's my full name in all caps. It used all that extra space. So what the trim will actually do is actually trim off any white space in the front and the back. So if I say system out print line, I can say trim white space on last name. And what I'm going to do is, wait, where's the plus sign? All right, so I'm going to get my last name. I'm going to call the method trim. And it's going to remove that white space. It's actually pretty useful when you're taking user input. If they put spaces in front and behind, right, you don't actually want the spaces to be part of the value that you're going to store, so that you can trim it off and you can get rid of it. Okay. So the space is still up here, and I didn't actually change the value of my full name. I just simply made a copy of it and I printed it out to the screen. But that's what the trim would actually do. All right, there's trim, there's equals ignore case, compared to ignore case. I'll do those ones last though. Oh, substring, that's actually a really good one. All right, so substring. Okay, so the way this works is you just get a portion of the string. Okay, so I'm gonna say substring of first name start at, we'll start at 3, end at 5. Okay, now before I actually show you this demonstration, let me hop over. Let me see if I brought my. Yes, sweet. Okay, so let me just kind of explain this really quick. All right, so the way that data is stored in a string is actually character by character in this container, and it's very similar to, the heck, why do I have to do this? It's very similar to using an array, which we'll talk about at the end of this semester. But here is my name, my first name. Okay, now the way to picture this is the string actually has all these characters in their own little separate box. Okay, their own separate box. The very first letter is at the position 0, not 1. That's just something you have to get used to, right? Because numbers actually start at 0. Okay, so the very first item in programming is always going to be at index 0 or location 0. The next one is going to be at 1, 2, 3, 4, 5, and then 6. So even though the length of my name is equal to 7, the last index is index 6. Okay, so the length of my name as a string is 7, but the last character is at position number 6, which is the 7th character, because we start at 0. Okay, you have to keep that in mind when you use this stuff. So I'm gonna hop back over to the code, and before I actually show you this, I probably should have started off with an easier method, which is char at. Okay, so I'm gonna say first name char at, I'm gonna say 0. I'm gonna say first name, and I'm gonna say char at. And I'm gonna say, oops, actually, it's a number that you pass in. You pass in the index of where the char is at, and I'm gonna also print out, say position 4. And I'll come back and I'll break it with putting a position which is out of range. But let me show you how this works first. All right, so at position 0, I have an M. At position 4, I have an A. If I hop back over to the drawing that I showed you, at 4, I did in fact have an A. So you can actually grab characters off that string at the different positions, but you have to be careful. So you have to actually know like how that's the size of your string, because if I try to grab something like at position 17, right, there isn't 17 characters in my first name. Now when I come over here to compile, it will compile. So it's not, so Java's not smart enough to know, hey, the string is this long, and you're trying to ask for index number 17. But the problem is going to happen when you actually get to that line in the code. This is what we call a runtime error. The program will actually crash once it gets to that part of the code. So here is a crash. Okay, it's telling you that string index is out of bounds. String index of range 17, and that's really all it gives you, right? Char at, and then telling you in the main method, line 22. Okay, so at line 22, it's basically trying to point to this method right here. All right, so runtime error, it just told you at position 17, there was no character there, it threw an exception. So that is a runtime error. So you have to be careful when you use this. Make sure you have something in range. You can always get the length of your string by just calling the method, oh, I misspelled first. Calling the method length. Okay, so I'm gonna say, here I'm gonna say length of first name. And it is a method, so you have the parentheses right there. Okay, and I'm going to clear my screen, compile, and run. You can see that the length of my first name is 7. So if I wanted to grab the very last character of my last name, or my first name, like what can I do? Okay, here's my name. I want to grab at index number 6, right? How can I grab the last character in my name? Right, the easy way would be to say, let's see, over here I'm going to say last char of first name. If you knew that, if you like, the easy way would just be putting the 6 here, right? But let's just say that the first name was inputted by the user, so you don't really know how long the name's going to be. I can put a 6 because I hard-coded these values in, right? So I know that position 6, I'm going to have an L. So when I come here to compile and run, you can see that the last char is L. But what if the name was different? Like they had like all these extra characters on this name. I come over here, compile, run. You can see that it still got the L, but it didn't get the true character, the last character in my last name, my first name, which was a D. Okay, then what you can do is you can solve this programmatically by using the length of your first name, right? So the last character of your name or a string is always going to be the length of the string minus 1, right? Everybody agree with that? So the length of Michael is 7. the last index is 6. It's always going to be -1. So if I wanted to grab the very last char of any string, I could just take the length -1 and then pass that into the value for the integer inside of the method char at. Okay, and there is the D, right? It was able to grab the actual true last character of the last name. Okay, any questions on that? So you can kind of like use some of this as and solve things programmatically. So if you see something like on your test, your homework that says grab the last character off a user's or off a string, and the data is inputted by the user, meaning you don't know how big or how long that string is going to be, the solution that you need to do is the length of the string -1, right? Here's the length 7. 6 is essentially 7 minus 1. And that's how you would get the last character. Okay, now substring is one of the more difficult methods to use. I always get it confused too, because every programming languages have different ways of getting a substring. And I believe Java's is a little funky. Let me just do first name, substring, I'm gonna say 1, 4. Okay, so the way this works, I have to actually test it to remember. You put the index of where you want to start. Like, I know that for sure. Okay, so if I just wanted a portion of this string, actually let me delete all this nonsense right here. If I just wanted a portion of my first name, to say I wanted the I, the C, the H, and the A, right? Just what's highlighted. I can call the substring method and grab a portion of it. So the first number that you pass into the substring is where you want to start. If you don't pass in a second value you put a comma, pass in a second value. If you don't pass in a second value, it's just going to go from the position you want to start at all the way to the end of the string, and that will be the portion of the string that you get back. To prove that, I will just run a quick example. So compile, run, and like this is a substring that came back. Okay, I only pass it where I wanted to start. I did not pass it where I want to end. If I wanted to end at index number 4, okay, this is where Java's kind of weird. Like, it just doesn't make sense to me. If I want to end at 4, I have to enter in the index of where I want to stop before, meaning you would add 1 to where you want to stop. So if I want to end at 4, you add 1, and you would have to put in a 5. Okay, I know that's super confusing, but I'm gonna come over here and I want to end at index 4, so I'm gonna put in a 5. I don't know, I can't really make sense of why that is. So come over here, compile, run, and you can see that I ended at index 4 because at index 4 I had the A, right? So the substring passed into values where you want to start, and the index after of where you want to end. So if you want to end at 4, you put a 5. You want to end at 6, you put a 7, that type of thing. Okay, any questions on that? That one's a little more complicated. That is one of the ones that I ask you a lot of on the test, and you'll see it on your homework as well. But it's one of the ones that you should just get comfortable with. All right, the last things to talk about for the string class is the equals method and the compare to method. So the equals and the compare to, the equals method is going to return true or false if the two strings are equal to each other. The compare to is going to give you back a number. Okay, the number is going to be relative of where the string comparison happens with comparing each character by the number it's given in the Unicode character set. All right, and we'll read this slide and maybe it might make more sense, but it's basically going to give you numeric value if something is greater than, less than, or equal to. If it's 0 and compared to, it's going to give you 0. If it's negative, that means the string was less than the other one. If it's positive, that means it's greater than, meaning it came after. And then you have like the ignore case in each of those. Okay, so, all right, I need a couple of strings here. Okay, string, let's call this one str1. gonna be super generic. I'm gonna call this one Apple. This one called Apple, and then string number 3 would be Apple. String number 4 is going to be orange. All right, so what I'm going to do on my first pass is I'm going to just say something here. Should probably, okay, so what I'm going to do, I'll put like str1 plus equals str2. I want to put the values out, that way I don't have to like guess at what I have entered in them. Okay, and then here I'm going to say str1. I'm going to call equals, and then I'm going to pass in str2. Okay, I'm going to do that for all 4, but only use 1, so there's only 3. Okay, yeah, it's only 3 permutations. So I'm going to compare string 1 to string 2, string 1 to string 3, string 1 to string 4, and I'll put the results here, here, and here. All right, let's see what that does. So I'm going to hop over here, clear my screen, compile, run, and then like right here is where I should put a space, dang it. Let me put a space. Wait, I almost closed that. That would have been bad. All right, so put a space there, put a space there, put a space there. Okay. All right, so this is what I'm looking at right here. Okay, so Apple equals Apple, all caps, false. Apple equals Apple, right? They're both, right? The capital A, it's true. Apple equals orange, it's false. You know, I should have probably done a 5th one where it was Apple, but with the lowercase a. Let me just change this to Apple. And make a 5th one called orange. All right. So copy this, flap it there, string 1 equals string 5. All right, there's my results. So Apple with capital A equals Apple with the lowercase a, it was false. All right, so the only time this was true is when each letter actually equaled the other one, right? That's when it was actually true. And if I were to copy all of this and run it again, but this time I say equals, and I'll just say ignore case. Actually, let me just put a space there. Okay, and instead of calling equals, there's a method called equals ignore case. Equals ignore case equals ignore case equals. All right, so now when I hop over here, clear my screen, compile, run, you can see this is the results of the ignore case. They're all true except for the last one when I was comparing an apple to an orange. Okay, because it ignored the case of the comparison when it was doing the comparison. So it said apple with capital A, right, and apple in all caps, that was equal to each other. It's true. Right, so you have the variation of the equals ignore case. The compared to, I know it's a little confusing, but I'm just going to go ahead and just demo it right now, and we'll talk about it next week when I go through the lecture. But what it's doing is going to return a numeric value based off of, it's going to basically determine if one string is greater than or less than the other. It's giving you back a number to determine that. And the reason why this is important is it helps us to sort strings inside of a container, right? So if somebody's name starts with an A, it's going to come before somebody's name that starts with a B, right? It does that type of thing. Now in this case, the strings that I've set up, a capital actually comes before a excuse me, a lowercase letter inside of the Unicode character set. If you look at the Unicode character set, the lowercase letters have a higher number. So that means when you actually do the compare, if you get a negative value on whatever it is you're comparing, that means it's less than. Get a positive, that means it's greater than. If you get a 0, that means that they're considered to be equal. So I'm going to change this real quick. It's called compare to. Compare to, compare to, compare to. All right, and it's the same, exact same. You just you invoke one off one string and pass in another. And it's you just a compare to ignore case as well. All right, I'm going to save that and clear my screen. Compile, run. Okay, so all of this happened right here, what's highlighted. So the first comparison returned a 32. If you actually look at capital A and, wait, take that back. Where did it mess up? Oh, actually, capital A were the same. Then it compared the P's. So the lowercase p and the uppercase p is what it compared. So it basically said that this apple here, this result is positive. That means that this apple comes after an apple in all caps. If you look at the p's inside the Unicode character set, the difference between the two is 32 spots. Meaning the capital P will occur in the Unicode character sets. If the 32 spots down, you'll see the lowercase p. Okay. When it compared apple and apple, it said it's 0, meaning they're the exact same. When it compared apple to lowercase apple, it gave us a negative 32 because it compared the uppercase A and the lowercase a and said negative 32, right? So when it compared the A and the O, it said the apple was less than the orange by 14 characters, right? When I ignored case, all of that was equal to each other, and this is the only thing that returned a value. Okay, we'll talk more about this next week. I do ask you questions on compare to, so it's something that you should understand. But I would say the best thing to understand about this is returns a negative integer if it's less than, a 0 if they're equal to, a positive integer if it's greater than. Okay, the object that the method is being invoked on would be what the result is referencing when it gives you the result. Meaning, string 1, I'm invoking compare to. So it's basically like me saying, in string 1 we have apple, and then in string 2 we have apple in all caps. Okay, so for this particular line that I have highlighted, it's like me telling Java, does apple with a capital A, does it come before, after, or is it equal to apple in all caps? If Java gives me -1, it says apple with a capital A comes before apple in all caps, which is not the case. If it gives me 0, it's telling me they're equal to each other. If it gives me a positive number, it's telling me that apple with the uppercase A comes after apple in all caps, is which exactly what it gave me. When I hop back over to my result, you can see that apple with a capital A compared to apple with a capital in all caps gave me back a positive number. You don't need to memorize like what number is going to return. You just need to know if it's negative, 0, or positive. Okay, that's what I'm looking for on my midterm. All right, any questions on the string class? Like, we're just gonna you're gonna have to get familiar with these. Your homework assignments are gonna actually have you use these methods. Now these are all the ones that the book covers. I don't think I left any of them off. And I did throw in the trim, which is something that book doesn't talk about, but I feel like it's something important because it's actually one of the methods that I use a lot, right? Which is one of the ones that get used a lot, is trim. Any questions on that? All right, so we still have plenty of time, like 30 more minutes. Is it 30 more? Yeah, 30 more minutes. All right, so I'm going to talk about the random class and the math class really quick. Those are actually really good classes to know. So I'm going to come over here, new, and save this one. I'm going to call this one random demo. This is actually a really interesting one because this is how you can generate random numbers that you can use in your program. Okay, so the way this random class works, it works just like the scanner class. It lives in the java.util package, so you have to import this class. You're going to say java.util.random, okay? And you're going to declare your class, public class, the name of your class, which I called random. Dang it, I messed up. I should have named it random. So, okay, anyways, I named it random, and then this class over here is named random. So now Java's going to be confused on which one to use, right? So this is what I'm about to do. I'm about to save this as random demo. Okay, and this is going to be random demo. Okay, but I'm going to have to actually go to the location and delete that file, because if I don't, Java's going to try to use that as my random class. You have to be really careful when you mess with these things. So come here, and I'm going to delete this one. All right. Delete. Yeah, delete everywhere. Okay. Hop back over here. So random demo, public, static, void, main, string array. Arguments. All right, so just like your scanner class, you have to declare a random object, right? So I'm going to instantiate a random object, and I'm going to say random, just like that. Okay. Now I'm going to use a loop here. We won't actually talk about loops until chapter 6, or at least the for loop is not until chapter 6. But I just want to demonstrate random numbers really quick. So x is less than, I'm going to say 100 iterations of this loop, x plus plus. And the way you get a random number is you just say system.out.print line, and I'll just say x plus colon space my random object dot next int. Okay, really simple. Okay, but the integer is going to be any random integer within the range of the lowest possible value for an integer to the highest possible value of an integer, so that might not actually be that useful. So I'm going to say Java C random demo compile. It compiles, that's good. And then run. Okay, so I ran it 100 times, and these are all the random numbers that were generated. Okay, it's within the range of an integer. That is probably not very useful to you. Okay, you can actually augment these values. So the way that you do this is, let me see, I want to keep this demo. So I'm going to copy what I did here. That way, if you can play with this if you want, you can see like all the, right, I'm going to slap it right here. All right, so what I'm going to do, the way this works is you can pass what we call a seed value to the next int, which is the number of random numbers that you want. Okay, so just say we want 10 random numbers. We'll just pass in a 10 right here, and it's going to generate 10 random numbers. And those 10 random numbers are going to be 0 through 9, because everything starts at 0, right? So if I said I want 10 random numbers, it's going to start at 0, and it's going to end at 9. So now when I compile and run, you'll see that it's just generating 0, and my highest value within 100 iterations was a 9. Okay, so I just randomly generated numbers between 0 and 9 by just simply passing in 10 here. So how do you think I can get 1 through 10? Like I want 1 through 10, like what can I do to generate a random number between 1 and 10? What's that?
11.
Put 11? Okay, so if I put 11, I'm telling this random class that I want how many numbers? 11 numbers, starting from 0, right? So if I were to compile and run, okay, I'm getting 10, but I'm also getting 0, right? So I'm not really getting 1 through 10. What's it? Would comma 11? No, that won't work. Guess.
So you'll do, you put in parentheses, I want to say you'll keep it as 10 and then add a +1 outside of it?
That's exactly right. Okay? So I know I want 10 numbers. So you won't put a 9, it's actually 10, right? Because I want 10 numbers, but I want the numbers to be 1 through 10, not 0 through 9. But what I can do is I can offset this value. Okay, I can offset this value right here by simply just adding a 1 to it, right? So what's highlighted is going to give me 0 through 9, but I'm adding a 1 to the result, so now I'm getting 1 through 10. Does that make sense? Okay, so, oops, I didn't mean to do that. Control Z, Control S, hop over here, compile, run. Okay, so now if you look through the results, you'll see my lowest value is a 1. I didn't actually get a 0. All right, so what if you want, this is a good one right here. Let me comment this. This is an example of 1 through 10. But let's just say that I want a different range. Something crazy like, how about 5 through 17? How the heck am I going to get that? Any ideas?
Would you, from 5 to 17, there's 12 values, right?
I believe so, right? I actually don't know. I'm just made this up on the fly. So so the first thing you got to do is tell the random object how many numbers you want, right? So how many values are between 5 and 17?
Well,
So like, how would you find that? You would take
13.
17 minus 5, right? And what do you get? But then you have to remember that you want to include the starting point. Right, so there's 13 numbers. Does that make sense? Because you're going to include where you start and where you end. So yeah, you're right, 13. Okay, good. Now how would I offset this? 5, right? And the rule of thumb is your offset is going to be the lowest value that you want. Okay? And what goes inside of here, where the 13's at, it's a simple trick. It's just, well, let me run this first, and then I'll show you the simple trick. It's just where you want to end minus where you want to stop plus 1. Okay, that's how you get that range. Okay, so I ran it and that didn't work. What the heck? Oh, I didn't compile. That's what happened. Or did I save? No, I didn't save. That's what I drew. All right, so I can scroll through and make sure that my lowest value is a 5 and my highest value is a 17. I do see 17. I already seen 5. I haven't seen any 4s or 18s, right? But it can work, okay? Pretty much just work. I'm gonna go ahead and comment this out. All right, so what if I just wanted the values, I don't know, 113 through 156. Okay, now the equation behind it, and it makes it super simple, is just to say that your range is A through B, where A is your highest value, or excuse me, your lowest value, and B is your highest value. Then what you're going to put in next int would be B minus A, okay, and then plus 1. Actually, you don't need to put that in parentheses because it's the order of operations. It doesn't matter. Okay, B minus A plus 1. All right, and then your offset is always going to be the value of A. So following that rule, I'm basically saying if I wanted to generate a random number between 113 and 156, all I really have to do is come over here and say, okay, well, 156 minus 113 plus 1. I can get a calculator, punch that out, and see what the actual value is. And then my offset is going to be whatever A is, which is 113. Okay, so that's going to give me random values between 113 and 156. If I come over here and compile and run, I can scroll through all this and find what my lowest value. I see 114. I need 113. Come on, 113, where are you? There's a 113. Okay, so my highest value was supposed to be 156, and there's a 156. All right, and you should probably look to verify that you didn't get anything less than 113. are greater than 156. But that's how you do the range. Okay, you can simplify this number. So 156 minus 113 plus 1 is what? 42. Okay, I actually don't know. Like, I can't do math that quick in my head. 43? All right, so that's the answer. Okay, so just remember this equation here. Okay, and it'll make your life a lot simpler because I will ask you questions on your midterm. Write a program that generates a random number between 7 and 21, right? And if you just use this method here, you can figure it out pretty quick. All right, the other thing that you should probably know about the random class, I'm gonna go ahead and comment this out for now. Actually, what should I do? I'll comment out for now, but this right here is probably the most important part to take away, what's highlighted. The other thing about the random class is it actually generates floating numbers, right? So if I do x plus colon space plus random dot next float, okay, you can't see this value. It's going to give you a random number between 0 and 0.999999999. Okay, there's no way to change that. Okay, so, but I just want to show you that you can do that with the random class is you can generate random decimal numbers. All right, pretty simple. Most important thing to take away is I'm going to go ahead and comment that part out and leave this part in. Actually, maybe that was a little too complicated. Well, I don't know. Let you decide. All right, so let me do an example of the math class. Because when math demo, you can go to Java API and see all the different math methods that you can call. So something important to know about the math class, which is the most important thing that you should understand, is you don't need to come up here and say import java.lang.math, because everything in the java.language package is already automatically imported for you. That's why we can use the string class without having to import anything. So public class math demo, public static void main string array arguments. Okay, so the math class, you don't do this. Okay, so in the math class, you don't actually have to instantiate an object of that class. All the methods on the math class are static. That's something else that you need to know. I'm going to put that down. It's very important. Okay, so when I say the methods on the math class are static, what that means is methods are invoked through the class name.
How would we create a random number generator that doesn't like repeat values?
Oh, you don't want to repeat a value? You wouldn't be able to. You would have to just put some logic in there to say if you do repeat, ignore it. You know what I'm saying? Like you have to kind of store the values that you've already generated into a list, and then like see if it's in that list. If it is in that list, then what you can do is just ignore it and then generate the next one. Checked. Yeah. Another way to do that, I mean, I don't know if you're familiar with using arrays, is you can put all the values that you want, right, from an array, like inside of an array, and then randomly generate the index of what you want, and then maybe have like another array, like with full of booleans or something that just says like, you've already guessed that one, you know? It's kind of complicated, but yeah, the only real way to do that is to keep track of what you generated and check to see if you already generated it. All right, so that means the methods are invoked through the class name. So that means that you can just come in here real easy and say, you know what, I want to know what 5 to the third power is. Where's the little up caret thing? Numbers, oh, thank you. I want to know what 5 to the third power is. And you can do this by just saying math.pow, I believe it is. Yeah, math.pow. And you pass in the 5, and then you pass in the power. Real simple. So now if you come over here to run your program, clear my screen, Java C, math, demo, compile, run, math demo. Okay, and there's the answer, right? I got the PAL. If you wanted to know things like the square root, so the square root, I don't know how to abbreviate square root. Square root of 169 is 13, right? So if I do the square root of 169, I should get 13. Right, and there's your answer. Okay, so there's a lot of useful methods that you can use. The book talks about the trigonomic functions like arc, cosine, sine, and all that stuff. You're gonna have to use them in your programming problems. I'm not gonna really test you on that. Or actually, take that back. Am I gonna test you? Yeah, you don't really have to know them. Like, I don't really test you on it that hard. You just have to know that they exist, pretty much. So, like, I might ask you a method, or I might ask you a question that says, out of the following methods, which one is not a method of the math class, right? And you're going to see things like cosine, sine, square root, POW, exponent, stuff like that. And there'll be something that is not part of the math class, okay? So I'm going to go over the ones that the book wants you to know. Another one is the exponent. You guys know what the E number is? The natural number, like E. Yeah, I don't know. I still can't explain it, but yeah, what's that?
What are those numbers? E?
It's at the E. Yeah, it's at like 2 point something, right?
Yeah. It's around that.
Yeah. So I'm going to say like that number to the fifth power. If you wanted to do that, then you just use exponent and just put the power that you want to raise it to, and it's automatically going to put like the E as the base. Okay. Compile, run, and then there's the result of that. The math class also has things that you can use for knowing what E is equal to. To say I want to know what E is, there is something called math.e. Notice that there's no parentheses because this is actually a constant, so you can invoke it through the class name. If I wanted to know what pi is as a double, then you can also get pi as well. Okay, now part of the coding standard in chapter 3, I do have you doing like volumes of a sphere and stuff like that. The equations are given to you, but whenever you need to use pi, I want you to use math.pi. Okay, so I'll come over here, I clear my screen, compile, run, and those are the values that you get for E and for pi. Okay, some of the other things that you'll see the math class do from the book is there's a method called seal. Now they say seal of 2.34 and seal of 2.99. And there's also one called floor. Copy these values. All right, so what these do is they're going to give you, like, they basically truncate the decimal place. Kind of like what we do for an integer, but if you use seal, it's going to basically round up, and if you use floor, it's going to just round down, no matter what the decimal place is. So if I come over here and clear my screen, compile, run, you can see that the seal of 2.34 is 3, and of 2.9 is 3, and the floor of those same values is 2. Like, those are two that I ask you as well on the midterm and on the final. I can't think of anything else. The math class does have a random as well, and it's going to work just like the float. The next float worked on the random class. So I'll just say like random. It's basically going to give you a random number between 0.0, meaning it can be 0, and 0.999999, except it's going to give it to you as a double and not as a float. So there is a method called math.random. Now, for some reason, that question I was telling you about the math class, I put the random as one of the methods in there, and a lot of students actually put that as the method that is not part of the math class, when in fact it is part of the math class. So just keep that in mind. That's like the number one guessed wrong answer. Okay, and it's just randomly giving me a float. If I keep running this, you can see it's changing, right? So it was like 0.4 here, 0.7 here, 0.86 there. All right, one of the other cool ones that the book doesn't talk about, but I feel like these are actually kind of cool to know, is something called max. I'll say max of 1.4 and 2.5, and there's something called min. And I'll say 1.4, 2.5. So it's going to do like some logic for you actually. So if you just call the math.max, pass in the two numbers that you're trying to compare, 1.4, 2.5, and min 1.4, 2.5. It's going to actually like do some logic for you and give you back the result of which one is the max and which one's the min. It's almost like using an if statement, right? Because you're just asking the math class to determine which one is greater. All right, and there's the result of max, and this is the result of min. The other really good one is math.round. If you wanted to round something, so let's just run around on a couple of numbers. I'll say, excuse me, 5.111. Say math round, and pass in 5.111, and I'll run it on a couple of numbers so that we can actually see how it works. So what if it's 4, 5? What do we get for 4, 5? What do we get for, 0.45 and then 5.5? And then I guess the last one we'll just do like 7 or something like that. All right, so come over here, turn my screen, compile, run. All right, and here are the results. Wait, I didn't do 5.56, what the heck? Wait, oh, I'm sorry. Oh, I didn't put a space. That's why. I should probably put an equal sign so it's not confusing. All right, so you can see the results right there, right? That's normally what we expect when we're rounding numbers. If it's not 0.5, we round down. If it is 0.5, we round up. If you look at it, it's actually returning an integer though, which is pretty interesting, right? Like over here, when I use the floor and the ceiling, it was giving me a double. So notice the 0.0 at the end of this, but this one is actually giving me back an integer. So you don't have the 0.0 at the end of it. Any questions on that? So that's pretty much it. That's what the chapter 3 is really all about. The programming problems are going to get a little more complicated because I can ask you questions like prompt the user for a first and a last name, then take the first char from the first name and the first 5 of the last name, combine them together and generate a username that has a random number between 10 and 99 at the end of that. Right, that's actually one of the questions from the book. Yes?
I was wondering, is there a particular reason to use math.random over the random class other than it coming out as a...
So, I actually prefer to use math.random, and the reason why I prefer it is because I don't have to instantiate an object.
Okay, that makes sense, because I knew in my high school Java class, we always just casted math.random as an integer.
Yeah,
I was wondering if there was
a lot of people do that because, so if I wanted to use the random class All right, like just say I want to generate a random number between 1 and 10. Actually, let me just put this in a quick for loop. Actually, I'll just go, well, I'll go to 100. Shit. Okay, so I'm giving you a random number between 1 and 10, and then what I'm going to do is just right here, all right, it's going to be kind of wonky, but I'm going to say like math.random. I know that's going to give me a value 0 to 0.9999, but if I multiply that to 10, okay, then I'm going to get 0.0 to 9.9999, right? But if I take that result and I cast it to an integer, then what I'm going to do is I'm going to get 0 through 9. And then if I wrap it one more time with parentheses and offset it by 1, then I'll get 1 through 10. And I didn't have to go import the random class and instantiate an object. Like, that's what I prefer, like if I'm just gonna need a quick random number, like I just prefer to use that really quick. And then when I come over here, on my screen, compile, run, right, it generated all those random numbers between 1 and 10, right, just the same way that I did for the random class. Unfortunately, on your homework, I do tell you use the random class, okay? But yes, once you get past chapter 3, I don't care what you use to generate the random number. So this might, if you're used to using this, you can use it. But in chapter 3, I do want you to use the random class for random numbers. Yes? You had a question?
For chapter 2 or 3, we use the random class.
Chapter 3, there's no random generation in chapter 2. Yeah. All right, well, that's all I have. You guys are free to go. Next class, we'll get into lectures, and we'll do quizzes at the end of the class.